We can start working.
And bro.
What's up guys, welcome back to day 5 of Robot in 1 week. Today we're going to be fabricating our RAM, putting on our shooter, putting on our intake, and since we made the code last night, thank you to one of our programmers, we're going to be testing the basic codes of the robot. I'll see you guys later.
So using our CAD, we're able to mount our motor. So right now, as we're putting on these mounts to hold our shooter wheel, we're 3D printing a piece that'll hold our motor on.
Didn't you take 10 seconds?
Okay, so basically I'm screwing in this intake mechanism to the servo, which is going to be on our robot right here. This is the ball, and it's going to go through this roller. And then to index it, we're going to use this servo mechanism right here, over here, with another pair right here, so that we can hold it over here while we wait for our rollers to get ready to shoot. If there needs to be any more tightening, I can do this. Thank you, sir.
So right now we're 3D printing this motor mount to mount our Go Builder motor onto the Rev channels.
So this is the final iteration of the flywheel we're going to mount onto our robot. So we're using the 2 stealth wheels that we've been prototyping with, and we're just mounting it on a shaft with the 30-tooth gear, and we're going to take this 90-tooth gear and mount it directly on our motor, and that's going to be our gear ratio for spinning the flywheel so we have more speed on it.
After testing, we did see that our motor was capable enough to shoot into the goal, but what we noticed is it was taking a long time to rev up to its top speed. So by doing this gear ratio, we can increase the speed and revving up time without having the motor running at its full power.
So we made pretty good progress on fabricating our robot yesterday. Our CAD is finishing up pretty well, so we're starting to implement some of the designs we sketched out on there. We have our indexing system installed with our servos and the flap wheels, and we have our shooter kind of superstructure built. We're working on mounting the motor today. So today we're going to work on finishing up the shooter, putting on our intake, and then putting on some of the custom polycarbonate pieces such as the shooter ramp and the intake ramp.
We decided to switch to the rev motor because 1, it's more compact, and 2, it gives us the same speed as the Go Builder motor that we were using previously. This also lets us use the 6mm head shaft, which is more versatile with the kit that we're using.
Tomorrow I'm gonna get my helicopter hat.
No.
I don't think you can catch that. If the mountain height gets in the way, we make it smaller. So essentially we ran into a bit of an issue where we found out that the core hex motor doesn't have as much speed as we expected. So to still be able to use it, we're going to gear it. And so obviously with gearing we get a ratio and we know it increases, but there is a specific RPM that we want to hit for intaking from our prototyping. We have a way of calculating that, and so we have our JVM design calculator. So it's the spreadsheet we have. We can plug in the free speed of our motor and the gear ratios, and from there it'll output how much rotational speed, and depending on the application we kind of change spreadsheet a bit, but it's pretty simple to use and it's super helpful for us to kind of estimate whether we need to increase gear ratios or decrease, or if we're hitting our speed. Oh, this is good. Can you get the other gear on? Yeah.
Welcome.
So this is the code we just made for our teleop program. So we have all of our motors set up and our continuous rotation servos for our indexer. So we just have motors for our tank drive, our shooter, and our intake, and then we have a left servo and a right servo for the indexer. Because we're doing a tank drive, we're gonna invert our left drive, and for our indexer, we're also gonna invert it as well. And then it's just super simple. We just have 2 controls, just like the left trigger is for our intaking, and then the right trigger is for shooting. So we index at full power and then also set our shooter to a certain percent power.
Also, over here we're doing our arcade driving. So with this, it makes it easier on the drivers to locate and drive around the field. Instead of worrying about where the robot is, they're worrying more about where the artifact is. Oh wait, I told you one.
You literally did.
I forgot that we're gearing it 3 times.
Alright, that was a productive day. We were able to mount our initial prototype directly onto our robot, and it works pretty well. And we also finished up our code for our robot, and we are ready to test it out as well as soon as the robot's completely done. Thank you for watching.